Welcome to the satellite communication course. So now here we understand a bus synchronization technique. So to understand the bus synchronization, so we should know that what will be the delay between the station there. So now bus synchronization process in the TDMA terminal equipment, and that will be occur after the initial acquisition process. So initial acquisition pulse to this bus synchronizer as well as the local unique word and a RUW word to this bus synchronizer. Means after the initial acquisition pulse, that will be continuously detected in the particular frame. Then the station transmitting some particular data, that is nothing but a preamble, and that will be received by the particular bus window. And then the station will detect what will be the local unique word. Then station will detect what will be the LUW word transmitted by it in a preamble there. And through that, the position of this local unique word with respect to that RUW pulse, that will give the exact position of that local bus in the frame. Means this will give you the which is the position. This synchronization will be done using this local unique word as well as the RUW pulse. But in the case here, if you see here, so that a reference station and a local station, the satellite delay both for the reference station and a local station, that will be common in the downlink. So this is about a delay at the transmission. This is about a delay at the transmission. But at the downlink, if you see that RB plus LB, the delay is a common here. But on the uplink, if you see here, the delay is the different. This is about a uplink. This one is about a downlink. So reference bus. This is nothing but a reference bus, and this is about a local bus transmitting by this local station. So now using this reference bus and a local bus, so we can find out that a preamble transmission time that will be received a local unique word, and that will provide you the correct location or a position in a particular frame. So that's why that frame counters will generate. Okay, now you can see that the frame counters will generate that particular exactly frame period with respect to whatever the delay for both the reference station as well as the local station. So the difference between that frame period generated in the reference as well as the local station, that will be measured by the phase detector. And according to that particular delay, then corrective action is to be taken here, we can say. And according to that, corrective action is taken by adjusting the local station frame count. Okay, the control circuitry for action taken place. Then it will adjust that local transmitter here. And after that, by adjusting this local station, after that, local unique word is in the correct position and then the full data bus is transmitted. Okay, so that is about a local loop. So the bus synchronization act as a what we can say that it's like a phase look loop here in the satellite. So here the local frame counter is continuously adjusted using this a detector, and it will generate that position of the local word unique pulse, and then it assign the position of that local unique word with respect to that received RUW pulse. Okay, the difference between that RUW and LUW pulse equals, then the position of that local bus in the frame adjustment will be stopped. So in that initial equation position, initial equation, so correction is necessary, and that correction is applied at the transmit side. Okay, here the reference pulse, here the correction will be applied at the transmit side, and then whatever the frame counter is there, that is for the reference frame counter, or we can say that local frame counter here that is to be used. That frame counter at the transmit side, that is about a local transmitter frame counter here, that will compensate that LUW, and then they will assign the position for this LUW with respect to that RUW there. And that's why that whichever the error is there occur, if there is a difference, and that will be corrected using this a local frame shift. But sometimes what happen, there may be a change in the position of the satellite orbit, or small drift in the satellite position. So then that REW and LEW will be changes. So that's why it is to be corrected at the local transmitter side. So now here, so time delay between that REW and LAW, that will provide the position error of the local bus. So wherever the position is there for the given particular local bus, so that can be corrected using that RUW and a LUW bus. So means we can say that in a TDMA frame structure, so we have a control bus. So data bus 1 for the station 1, data bus 2 for the station 2, data bus n for the. So now the position of this particular data bus for the given station will be achieved using this technique there. So that is about a bus synchronization technique, and that will be achieved by the obtain the error between that RUW and a LUW pulse. And then we can calculate that what will be the frame efficiency of this particular TDMA frame. So frame efficiency is equal to whatever the user data bits with respect to that total bits in the frame. Or we can say that it equal to 1 minus overhead bits divided by total bits in the frame. So we can say that a frame efficiency NF is equal to 1 minus capital N PP BC here divided by PM, where N is equal to a number of data bursts and a BP that is equal to the number of bits in the preamble, then a BC is equal to number of bit in the control bus, and PF is equal to number of bits, okay, in the frame. Number of bits in the frame. That is about the total. So means that frame efficiency, it is just like a ratio of the user data bits to the total bits in the frame. So that is about a efficiency or TDMA frame. That frame efficiency is nothing but that what percent of the data transmitted and at actual what will be the information utilization there. So that is nothing but the frame efficiency there. So with this, we will say that the end of this a TDMA here. So we have learned that a FDMA system earlier, and in FDMA we say that so it will have share a frequency spectrum, which we can say that if whatever the spectrum is there, that will be shared by the user. That spectrum is shared by the users all the time in a FDMA, which use every user or each user they will share a spectrum all time in FDMA. And if you see that a TDMA, so whatever the users are there, users share a available time, users share a available time or a part of a frame time or a part of the frame. Okay, so users share a available time in the entire spectrum. So that is about the difference between that a TDMA and a FDMA here. So means that frequency spectrum is available to the users for all the time. But in this case, in that entire spectrum, a small or a specific time is available for the user from this entire spectrum. And that is about we conclude here with the TDMA and FDMA. and then we'll see that in next access system, that is about a code division multiple access system. With this, we'll end here. We stop